right, so here we are with level 2 elimination. So you might have noticed that when we were solving in level 1, we always immediately had opposites, exact opposites. When I go through the steps here and I line them up, 6x and 9x are not exact opposites. 2y and negative 4y are not exact opposites. So that means if there are no exact opposites, we need to make exact opposites. And the way that we do that is actually by multiplication. I think that this is the coolest part of these types of problems, is that when we're dealing with equation, we can basically, as long as we do the same thing to both sides, we can do whatever we want. So when I'm looking at these two equations, 6x and 9x are not that close to being opposites, but 2y and negative 4y are close. And I'm saying that they're close to being opposites because I can take this 2y, and let's think what is the opposite of negative 4y? Positive 4y. I can make 2y the opposite of 4y by simply multiplying both sides by 2. Now bear with me, I'm going to show you what I mean by this. So if I take this top equation and I multiply everything by 2, no, let's do erase. What the heck is going on? What I can do here, this is ridiculous. Okay. If I multiply this whole equation by 2, I do 6x times 2, that gives me 12x. I do positive 2y times 2, that gives me positive 4y. And I do 2 times 30. Remember, whatever you do to one side, you have to do to the other in equations. So this time I'm multiplying everything by 2. Now if I take this other equation and I line it up right underneath, 9x minus 4y equals 3. You see how now we do have exact opposites? And I can solve this, right? Now I can box these and cross them off. I'm left with 21x is equal to 63. I divide by 21, I divide by 21, I'm left with x equals 3. So I can force there to be opposites. I can force that by saying oh, you're not exact opposites yet, but if I multiply this by 2, then now I have exact opposites. Let's try another one. So using multiplication, I'm going to do another one. Let's say we have, let's do, trying to find a good one. Okay, so now we have this one right here, 2x minus 2y equals 4, and 6x minus 2y equals 12. So when I'm looking at these, I don't see any exact opposites yet. But I know that I can manipulate, I can multiply one of these equations in order to force there to be opposites. So I actually think that these two are really close. Negative 2y and negative 2y, they're already the same number. I just need one of them to be positive instead of negative. I know that a negative times a negative makes a positive. So I can take this whole top equation and multiply it by a negative 1. Negative 1 times negative 2x leaves me with a positive 2x. Negative 1 times negative 2y leaves me with a positive 2y. And negative 1 times 4 leaves me with a negative 4. Now when I copy down the second equation right underneath, check it out. I now have exact opposites. I can eliminate these and I'm left with 8x equals 8. And I can solve that no problem. All right, let's try a few more. Another really cool thing about this is that actually, as long as you're eliminating one of the variables, it doesn't matter which one you choose. So I can look at this and decide, oh, I want to eliminate my x's by multiplying this by 7, because that will give me a negative 7x. Or I can take this and say, I actually want to eliminate my y's. If I take the bottom equation and multiply it by a negative 3, that will end up me with a negative 6y, which is the opposite of positive 6y. So no matter what you do, as long as you're trying to force there to be exact opposites, you're probably on the right track. Go ahead and try some of the problems on your own.